Hello children, today's video we are going to prove if n is an integer, given that n is an integer and also given that n squared is even, we'll have to prove that n is also even. So what do we have to prove? That to prove n is even. But what is given to us in order to prove that n is even? What is given to us that n squared is even? These are n being an integer. So let us proceed with the proof. And now we are going to prove this by a method called proof by contradiction. Now I have posted a detailed video to explain you the meaning of proof by contradiction method using an example. I recommend that you have a look at that video before coming here so that you understand this proof clearly. Now this is a very important property and you will have to understand it for further proofs such as root 2, root 3, etc. are irrational numbers. In proving that, you will use this property. So let us start our proof. Now we are going to prove that n is even, and let us assume the contrary. Let us assume the opposite. The assumption would be n is odd, and proceed with logical explanations and see where we go. So we have assumed that n is odd. So n being odd can be represented as 2n plus 1, which is an odd integer. This is even, 2 into n is even, plus 1 is odd. So squaring both sides, what do you get? N squared is equal to 2n plus 1, the whole square. Now 2n plus 1 into 2n plus 1 would be n squared is equal to 4n squared plus 4n plus 1. Now look at this expansion carefully. You have one term 4n squared, which is an even number because it's a multiple of 4. Now this term 4 into n is also an even number, being a multiple of 4. Addition of 4n squared plus 4n is even. So when you add 1 to this is an odd number clearly. So now all this indicate that n squared is odd. But what is given to us? It is given that n squared is even. So where have we gone wrong? What is the contradiction? We have assumed that n is odd. We have assumed that n is odd. So we have arrived at the conclusion that n squared is also odd, which contradicts our given statement, isn't it? So what is our conclusion now? Because n squared is odd contradicts our given statement that n squared is even, our conclusion is if n squared is even, then n is also even. I hope you understand. Thank you.